All right, welcome to another deep dive, everyone. And today we're tackling a topic that's, well, kind of close to all of us, right? I mean, literally, we're talking about our eyes.
Yeah, vision, one of those things we kind of take for granted until maybe it starts to, not work quite as well as it used to.
Exactly.
Yeah.
And this deep dive is actually inspired by you, our listeners. We've had a lot of questions about vision, how it works, how it changes over time. So we went digging, and let me tell you, we've uncovered some fascinating stuff about this incredible sensory organ.
We really have. From the basic anatomy of the eye and how it moves to the typical changes we see as we get older, we even delved into some of the common tests used to assess vision.
So get ready, folks. We're going to break it all down for you in this deep dive, giving you a clearer, picture, I guess you could say, of this amazing system that lets us see the world.
Absolutely. We want you to walk away with a better understanding of how your eyes work and how to keep them healthy throughout your life.
Okay, let's dive in. So first things first, how do we actually see? One of the things that intrigued me was this idea of a single image visual system. We have two eyes, right? So how do we end up seeing one seamless image instead of two separate ones?
Well, it all comes down to a remarkable collaboration between our eyes and our brain. Each eye captures a slightly different view of the world, but then our brain steps in and does something pretty amazing. It takes those two separate images and merges them into one unified picture.
So it's kind of like our brain is doing some serious editing work behind the scenes, constantly stitching those two images together. But for that to work, our eyes need to move in perfect sync, right? I mean, the material talks about 6 cardinal fields of gaze. What exactly does that mean?
Right, so imagine your eye as capable of moving in 6 primary directions: up, down, left, right, and then 2 diagonal movements. Each of these directions is controlled by a specific pair of muscles that attach to the outside of your eyeball, called the extraocular muscles.
It's like having these tiny little motors controlling these really precise movements. And it makes sense, right? To get a smooth single image, your eyes can't be jerking around all over the place.
Exactly. These coordinated movements ensure we can track objects smoothly and maintain that single, clear image. And the control center for all this, orchestrating these movements, are 3 cranial nerves. You've got the oculomotor nerve, or CN third, the trochlear nerve, CNIV, and the abducens nerve, CNDI.
Ah, yes. And there's that handy mnemonic to help remember them. 3, 4, 6 makes my eyes do tricks. So we've got these 3 nerves acting like conductors of this visual symphony, making sure our eyes work together as a team.
I like that analogy. It really highlights the level of coordination involved. And to connect this to the bigger picture, this synchronized movement isn't just about seeing a single image. It's crucial for depth perception, judging distances, and even our overall spatial awareness. It allows us to interact with the world accurately.
Wow, that's incredible. Now let's zoom out a bit and think about how vision develops from the very beginning. It seems like a newborn's visual world is quite different from ours.
Oh, absolutely. When babies are born, their visual system is still maturing. Their peripheral vision is pretty much there, but their central vision, what they see directly in front of them, is a bit blurry.
So all those adorable baby photos where they're kind of looking off to the side, that's actually a pretty accurate representation of what they're seeing.
Pretty much. It's because the macula, that central part of the retina responsible for our sharpest vision, is still developing.
The macula is like the high definition area of the eye, right?
Exactly. And it takes about 8 months for the macula to fully mature, which explains why babies gradually gain better focus over those first few months.
That's fascinating. The material also talks about the lens of the eye changing as we grow.
Yeah, that's another key part of visual development. The lens in a baby's eye is soft and very flexible, but as we age, it gradually becomes firmer, almost like it turns into glass.
Oh, that makes sense. I guess that hardening of the lens is why so many people need reading glasses as they get older. They can't flex as well to focus up close anymore.
Right. That's presbyopia. It's a very common age-related change. And speaking of age-related changes, there's another important one to mention: the size of the eyeball itself.
Our eyeballs actually grow.
They do. They reach their full adult size around the age of 8. So between the lens changing and the eyeball growing, there's a lot happening in those early years. And that's why regular vision screenings for kids are so crucial.
Makes sense. Catching any problems early on can make a huge difference in their long-term vision. Now let's talk about those changes that tend to happen as we get older. Most of us will experience some shifts in our vision as we age. What are some of the most common ones?
Well, as we mentioned, the lens becomes less flexible, leading to presbyopia and the need for reading glasses. You might also notice your pupils don't dilate as much in dim light.
Like it takes longer for our eyes to adjust to darkness.
Exactly. And in general, our visual acuity, or sharpness of vision, tends to decline gradually over time.
So things might seem a little blurrier or less vibrant than they used to.
That's a good way to put it. And it's important to be aware of these changes because they're completely normal.
Now, the material also dives into some more serious age-related eye conditions, like glaucoma. That one seems particularly concerning because it can affect your peripheral vision first, right?
That's right. Glaucoma is a condition where the pressure inside your eye builds up. Imagine your eye like a balloon. Too much pressure can damage the optic nerve, which is responsible for transmitting visual information from the eye to the brain.
And the problem with peripheral vision loss is that you might not even realize it's happening until it's more advanced.
Exactly. That's why regular eye exams are so critical, especially as we get older. And it's worth noting that glaucoma is more prevalent in certain populations, particularly Black and Hispanic individuals.
So it's definitely something to be mindful of and talk to your doctor about. Okay, next up we've got cataracts.
Cataracts are basically a clouding of the natural lens of your eye. It's like looking through a window that's becoming foggy or frosted.
So things will look blurry or hazy.
Exactly. And colors might seem less vibrant as well. Fortunately, cataract surgery is a very common and effective procedure to restore clear vision.
That's good to know. Now, macular degeneration sounds particularly scary because it affects the macula, that central part of our retina responsible for sharp vision.
It can be very impactful. Macular degeneration causes damage to the macula, leading to a blurry or distorted patch in the center of your vision. Imagine a blind spot developing right in your direct line of sight.
That would make things like reading or recognizing faces extremely difficult.
Absolutely. It can significantly impact daily life. And lastly, we have diabetic retinopathy, which is a complication of diabetes.
So this is where high blood sugar levels start to damage the blood vessels in the retina.
Right. When those tiny blood vessels are damaged, they can leak fluid or bleed, and even abnormal new blood vessels can grow. All of this can interfere with the retina's ability to process light properly.
Leading to vision problems.
Yeah. It can range from blurry vision and floaters to more severe vision loss if it's not managed. That's why keeping your blood sugar under control is so important if you have diabetes.
All right, that covers some of the more serious conditions. Now let's shift gears and talk about the Snellen eye chart. It's such an iconic part of an eye exam, but what exactly is it telling us?
Well, the Snellen chart is used to measure your visual acuity, which is basically how clearly you can see at a distance. The basic setup is pretty simple. You stand 20 feet away from the chart, cover one eye, and try to read the smallest line of letters you can make out.
And then we get those results like 20/20 vision, 20/40 vision. What do those numbers actually mean?
Okay, so the first number, which is almost always 20, is the distance in feet that you're standing from the chart. The second number tells you the distance at which someone with normal vision could read the same line of letters that you just read.
So if I have 20/40 vision, it means I need to be 20 feet away to see what someone with normal vision could see clearly from 40 feet away.
Exactly. It means your distance vision isn't quite as sharp as someone with 20/20 vision.
So a smaller second number means better vision, right?
Yep. 20/15 vision would mean you have better than average visual acuity. And on the flip side, 2200 or worse is considered legally blind.
Wow, that's a big range. Okay, now beyond just reading letters, what other things do eye exams involve? I know they usually look at your pupils. What information can they get from that?
Looking at your pupils can tell us a lot about the health of your eyes and even your nervous system. They check the pupil size, shape, and how they react to light and changes in focus.
What's considered normal for pupil size?
In normal light, pupils are usually between 2 and 6 millimeters in diameter. They should be round and equal in size. And when light is shown into one eye, both pupils should constrict.
So that's a good sign, right? But what if they don't react the way they should?
Well, any abnormalities in pupil size, shape, or reactivity can be a sign of underlying issues. For example, unequal pupils could indicate nerve damage, while fixed and dilated pupils might suggest severe brain damage.
So it's definitely not just about how well you can see the letters on the chart. There's a lot more going on during an eye exam. The material also mentions something called the corneal light reflex, or the Hirschberg test. What's that all about?
The Hirschberg test is a simple way to check if your eyes are properly aligned. The examiner shines a light at your eyes and observes where the reflection of the light falls on your cornea. If the eyes are aligned, the reflection should be in the same spot on both corneas.
Oh, that makes sense. And then there's that acronym I've heard before, PERARLA. It stands for.
RLA stands for pupils equal, round, react to light, and accommodation. It's basically a shorthand way for doctors to document a normal pupillary exam.
So if your chart says Pearl A, you're good to go.
Pretty much. It means your pupils are functioning as they should.
Wow, this has been a truly eye-opening deep dive, no pun intended. We've covered so much ground, from the basic mechanics of how our eyes move to the changes that occur as we age and some of the common conditions that can affect our vision.
It really is an amazing system, one that we often take for granted until something goes wrong.
Exactly. And now, thanks to this deep dive, we all have a much better understanding of how this incredible sensory organ works and what we can do to keep our eyes healthy for years to come.
And it makes you wonder, what other subtle ways are our senses shaping our experience of the world without us even realizing it? How does our vision interact with our memories, for instance? Or could those gradual changes in our vision even affect our perception of time?
Those are some great questions to ponder. We'll have to save those for another deep dive. Thanks for joining us today, everyone. Until next time, keep those eyes peeled.
And take care of your vision.